Hi, everybody. My name is Chen Sagiv. I'm co-founder and co-CEO of DeePathology. And in this movie, I want to quickly train together with you an AI solution for finding regions in a TCGA slide. So first of all, I want to share my screen with you. Okay. Now, what do we have here? We have the DeePathology STUDIO web platform. It is now running on a cloud, which is located in Germany. It's a web-based platform. And what I want to do here is I want to train an algorithm to differentiate between tumor area and necrosis. Now, it can be even more sophisticated to add the stroma and vessels and up to 10 categories, but I want to keep it simple here. So, the whole idea with the DeePathology STUDIO is that we have pre-trained algorithms for the different problems of region segmentation, cell quantification, object detection, etc. And the way that we tune the algorithm or the pre-trained solution to our specific use case is by providing annotations. So what I'm going to do now is I'm going to provide annotations for necrosis and for tumor, and I let the system train. So necrosis is going to be in green, and what I'm going to do is I'm going to give it like a few samples. I would aim to around 10 to 12 examples. So let's go also here. How many examples? 9. Okay, so let's. Yeah, okay. So this is 12 examples, and this should be quite good to get started. Now, tumor area would be in pink, and I'm going to annotate it. Okay. Okay. That's very relaxing, to be honest. All this training, all this annotation. Let's go maybe here and annotate a bit more. You see that it takes a bit of time, and the real reason for that is that it's actually in the cloud, so it takes just time depending on my internet connection. Okay, so I also have like 30 examples of tumor, and now I want to provide examples of pure background. And the background can actually differentiate between slides and use cases and stainings. So I just want to have it as a degree of freedom and to say, okay, this is what I'm not interested in at all. This is a category which is definitely not of any interest for me. And you can see that only after a few annotations of the background, I got the training in action. So the training actually got started, and the generic module is now being adapted to solve my specific use case. So I have to give it some time to train. And in the meantime, what I can do are two things. I can review my annotations. This is some kind of a sanity check just to make sure that my annotations are correct. Because when you have a supervised model, which means that we are training an AI solution according to some ground truth, if my ground truth is not correct, I will also have an erroneous algorithm. So this is a very important sanity check. Let's look at the necrosis. I can change the resolution as well, just to get, to change the context. So this looks pretty okay. Let's go to the tumor. Yeah, this also looks okay. I can also zoom in just to make sure. Cool. And background. Okay, so this looks quite good. My sanity check is okay. The next thing I'm going to do is to see how the training process is really going on. And what we provide in order to visualize that are the graphs. These are graphs of the F1 score for this segmentation problem. And for each category, we provide the F1 score. You see that the x-axis is the epoch number. So already we have over 25 epochs, which means that we train and train and train the system with the data we have provided. And this is the F1 score. So we can see here, yeah, that this is settling down, which is a very good timing to try to deploy it. Now let's look for a cool region for the deployment. I want to have a region which really has tumor as well as necrosis area. So I think that this could be a pretty nice location. And I know that there are more subtle categories here, but I'm not going into that. So let's deploy the algorithm on this region of interest. You see, this is the actually the signal that the deployment is going on. And you see that the training and the deployment can be done in parallel. Okay, what do we have? So these are very, very, shiny colors, but I want to see whether this is correct or not. So I can change the opacity and reduce it. Okay, and now I can see that the necrosis was found pretty okay, as well as the tumor area. But in between, so right here, the algorithm is a bit ambiguous because, yeah, it's not typical. I mean, I could mark it as a different category or as a background, but I think that for a very, very initial result, this is a very, very cool result. So this is how we get started with the DeePathology Studio. In the next videos, I'm going to show you some more. Take care. Bye for now.